Hi everyone, welcome back to Hidden in the Stars. On today's short, we will be briefly covering what all the different variables in the Drake equation stand for. The Drake equation is essentially a derived equation that calculates the estimated number of technologically advanced civilizations in the Milky Way. Notice I say in the Milky Way, our galaxy. There are 7 components to the Drake equation besides the answer itself. It's important to follow them in the order they are read. You'll see why when I explain them and the progression in their descriptions. The equation reads as follows: n equals r times f sub p times n sub e times f sub e times f sub I times f sub c times L. Yay, this math has no numbers. Don't worry, I've got you. Let's break it down. N is the answer. It stands for the number of technologically advanced or intelligent civilizations in the Milky Way. It's computed by multiplying together all of the following. R, which stands for the rate of formation of stars in the galaxy. Little letters down to the right of the main variable are referred to as sub, so when you hear me say a letter sub another letter, that's what I mean. Next, F sub p stands for the fraction of the stars we just looked at in the letter R that have planetary systems. Ignore all stars that don't have planets. Next is N sub e, which stands for the number of planets per solar system that have an environment sustainable for life. There are certain criteria under which this follows, but we won't specify those here for sake of simplicity. Then there's F sub e that stands for the fraction of those planets on which life actually appears. F sub I is the fraction of planets with life on which intelligent life emerges. F sub c is the fraction of those intelligent civilizations that, as NASA puts it, quote, develop a technology that releases detectable signs of their existence into space. Finally, the L is the length of time that they release these so-called detectable signals out into space. All in all, the Drake equation is meant to tell us if we're alone in space. However, due to the unknown variables, it's never been solved. If you want to call the answer to it being solved, solving it would only prove that we have company. What do you think? Are we alone? I hope you have a little better grasp of this complicated looking equation, which isn't all that complicated once you know it a bit more. Join us on our journey through the cosmos. Catch you next time on Hidden in the Stars.